So we have two graphs here. One is function of x fx and another one is function of x gx. There is also a straight line here. Now for the first case, fx along with x-axis, they together enclose an area which is this one. And similarly the second one, gx, the line x is equal to a, this straight line, and x-axis, they form together another area which is, they enclose this area. Now these of the one of these area, any of these areas, so let's consider the first one. If this area is revolved around any of the axis or maybe around any straight line, a volume will be generated, and that volume can be calculated using integration, which we will discuss in this video. So I will stick my discussion into the first function. So let's consider this one, and let's consider this one is rotated about x-axis. Now there are two methods to solve these kind of problems when the volume, to find the volume by revolution. One is called disk method and another one is called cylindrical shell or washer method. So in one case the volume generated is like disks or several disks stacked together. So let's consider the first one. We'll consider the disk method, and here it is rotated about x-axis. So if we take this small section and if we consider the width of this section or this interval to be dx, very small one, infinitesimal small, and this height here, it is basically fx at that value, or we can say y. And if this one is rotated about x-axis, what we will get is, we will get a disk which is a circular disk, essentially a solid circular disk, and the circular disk will be like this. It will have the radius fx or y. So the surface area of the circular disk will be pi y square, because that's the area of the circle, and there is a width of that disk which is dx. So if we want to find the volume of that disk, we will multiply it with dx. This is the volume of just one disk, any arbitrary disk. It could be here or any of these. And then in order to calculate the whole volume, what we do, we have in theoretically infinite amount of these disks, so we basically integrate them. If this point is a and if this point is b, we integrate from a to b, which will accommodate all the disks. So all the disks are stacked one after another basically. So this is the way we find the volume by revolution using disk method. This is called disk method. Now if we consider the same area, and if we consider the revolution around revolution about y-axis, then we will have a different kind of volume generated. We have to consider that, and for that we will have to resort to the cylindrical shell method or washer method, which is called. So let's draw this again. Let's say this is our graph, and let's consider a section, this one. And if we say that this is our section, when this one is rotated about y-axis, we will have something like this, which is essentially a cylindrical shell with a hole inside, because this one is rotating. This is not here. If it were here, we would have a solid disk, but we are not getting a solid disk. We are getting a cylindrical shell with a hole inside. So if we say the radius here, the average radius will be x in this case. So the radius is x. I will just write them down. And if we just take this volume here, the structure here, and make it just stretch it as a straight structure, it will be like this. So this is the radius, which is x, the height here, in this case the height is fx, which is this one. I cannot show it here because it will actually go like that. So this can be called the height fx, and this one, since the radius is r, the perimeter will be 2 pi x. So perimeter is 2 pi x and height is fx. So this one is fx and the perimeter is 2 pi x. So if we want to find what is the surface area, that will be 2 pi x fx. That's the surface area of one of these shells, any of the shell basically. And if we want to find the volume, we have to multiply by the thickness, and thickness is again dx. Thickness is this one. So basically thickness is this one, which is, if we consider this one, basically this one, this is dx, this is the height, which is fx, and then radius of course is x. So height is fx, thickness is dx. When we multiply by dx, we get the volume of one shell. And as we, again here we have many shells, one inside another shell, inside there will be another shell with different sizes of different radius of course, and so different perimeter, but we will have the same thickness or dx basically. Height will also be different because fx is changing. So anyway, if in that case we will again, once we find the volume of one shell and we integrate them all, which is a up to from a to b, to get the whole volume of the whole revolution basically. So this is the shape is generated here is cylindrical shell. That's why it's called cylindrical shell method or washer method, and the formula is different. We are calculating the surface area, then multiplying by the thickness, which is basically dx. So I will do example problems in one of the in probably the next video.